Good afternoon and welcome again to the CERIAS Security Seminar Series. We're very happy this afternoon to be hosting a speaker from McAfee Corporation. George Heron has been in the computing industry for over 30 years, the last 20 in security. His job as chief scientist at McAfee is to look at trends in technology, look at new problems, find solutions, and ensure that they find their way into the product line to help customers at residences, businesses, government agencies protect their systems against all kinds of threats. One of the technologies he's been tracking, and he'll be talking about with us today, is in the area of virtualization. This is a technology that is being promoted by a number of companies, being built into hardware, offers a number of very interesting challenges and opportunities in security lifecycle management. And so without further ado, please join me in welcoming George Heron. Thank you, George.
Thank you, Scott. Thank you all. It is a great pleasure to be with you here today. We're going to move at a pretty good clip. I have some information that I'd like to be presenting as I describe it, a convergence of the security field and that of virtualization. Virtualization, of course, being rather new in some of our technical approaches to using computer systems and extolling different kinds of capabilities from them. Security, on the other hand, has been around for a while, and I just show the latest years here on how the different kinds of security solutions have been coming along, and industry finds a solution, and another problem comes along and we find a solution. First there was polymorphic viruses back in the early days, and again the early days for security dates back into the 80s when boot sector disks, and I suspect some of you still remember what a floppy disk is, and some of the sneaker net communication from computer to computer that propagated viruses. And the viruses then were kind of simple, straightforward, relatively show-off in nature. The guys back then, the people doing this writing of the malware were doing it for glory, for notoriety, for showing off to their friends, and so on. And each time that a new threat came out, whether it was in the early days of the polymorphic viruses, the zombies moving up to mass mailers, even as recent as in this 2001, 2002, every time a new problem would come about, security industry would come up with a new solution. New problem, a new attack comes out, a new solution. So I kind of consider that as a bit of a sequential, incremental type of technology improvement. However, now when we're looking at the opportunities coming along for virtualization, we see a new opportunity for both the good guys and the security providers such as McAfee, as well as the bad guys, the writers of the malware. Virtual systems themselves have been around for a long time too. Virtual systems can be viewed as starting back in the early days of maybe the IBM 370 with time sharing as a form of virtual systems. You had the only control of your particular your application, and from all intents and purposes your application was the only one running. You had full command of the resources. You had the full ability to you had the whole computer, whereas of course you really didn't. And in the later years, 2000 and onward, Vmware has really come up in the product world as having a robust virtualization platform for the most prolific platform in existence today, that is Windows, Microsoft Windows. So the opportunities are there for a company such as VMware, for developers such as you, maybe someday, and researchers to be really capitalizing on and using virtualization going forward. Well, I suggest that there is a convergence of these two areas, path one, security, path two, the virtualized systems, that is going to yield some really interesting and novel applications that have not yet been discovered, have not yet been capable. So that this convergence of security and virtualization really is at the essence of my discussion today. Of course, McAfee is very interested in security solutions. We are the only pure play security vendor in the industry, and others dabble in operating systems. Other Others who do security dabble in storage, disk storage, and facilities and so on. McAfee only does security, so it's sort of natural that I believe through some of our own internal work we are leading some of the thought. We are the thought leaders in the areas of applying virtualization techniques to the area of security. Now, a little bit of basics, but from a virtualization perspective, what is virtualization? It's a way for your application or one's application running on a computer to believe that it has the full command of the resources of that computer. Oftentimes it's the exclusive use of that computer, whereas there can be multiple OS images sitting on that same computer thinking the same thing, that it too has the same exclusive access to the resources. So the virtualization is really a virtualization of the hardware computer system, and this allows for many benefits to come about that we'll talk about in a bit, but in summary it's scalability of applications. It is for backup and redundancy purposes. It is for offsite storage and in general what I call operational aspects, operational IT aspects of a data center, fundamentally for the enterprise. Along the way, by the way, what I'll be talking about is the applications of virtualization and security from the perspective of an enterprise use. What IBM, what McAfee, what a large university, what the U.S. government would use in its managed environment for security throughout its entire population. However, also, to a lesser degree, but equally important and equally exciting to me, are those applications of virtualization and security in the home market. So you have computers at home. Some of you have children who are banging away on the keyboard and such. I suggest, and I'll explain how there are ways that the virtualization plus security equation can equally benefit the home environment. It's a different situation there. It's not as managed. Oftentimes you, especially you folks here, are the ones who are the systems administrator for your network, and therefore tools and techniques would be different than those used in the enterprise. As the chart shows here, there are two models in general for virtualizing the hardware. The model shown on the left is a host OS based, and it shows two guest operating systems, and again these OS images are sitting atop a virtual machine monitor, which serves as that interface to the hardware below. So fundamentally that VMM, that virtual machine monitor, is looking upward, providing an upward visibility to the OS images running on top that present the entire computer system resources available, the disk, the memory, even down to the CPU type of access. So the OS, the images that are, the applications running in the OS is up there, think that they're talking down directly to the hardware. It's just that there can be multiple of them. To the operating system, the virtual machine monitor looks like an application. It's sitting on top of there, and it's asking for resources, and it's giving response back and controlling. Frankly, that is the kind of environment that we see in the home environment, at least, and I'm speaking from the term, I'll be speaking a lot in terms of VMware. It's probably most understood by a lot of us. Other Linux-based systems, and XenSource is another good one, is more prevalent in a lesser community and also in the server community. But I'll be speaking from the VMware perspective. Vmware Workstation is this host-based type of system that you would see in the home use. Developers use a lot of this for their purposes of switching back and forth among different services that are running, having a computer node that is running as a server, another VM is running as a client, and then development can happen with that in that manner. The model on the right, the server, the hypervisor-based, is one that is typically used in the enterprise at the server level, and it essentially takes that VMM and host operating system and combines it and provides several services within it, as indicated by shown here. Essentially,